Today we're diving headfirst into the world where AI tackles some seriously hardcore math.
And not just any math, we're talking about the kind of geometry problems that would make even a seasoned mathematician break a sweat.
Yeah, those international mathematical Olympiad problems, right?
Exactly, the IMO, those are like the gold standard of high school math competitions.
So we're talking about problems that most people would struggle even to understand, let alone solve.
Precisely, and that's what makes this deep dive so fascinating. We're looking at an AI system called AlphaGeometry that can actually crack these problems.
So we have an AI that can do high school math. What's the big deal?
Well, it's not just about solving for x or calculating an angle. We're talking about a whole other level of mathematical reasoning here. Alpha geometry is tackling what's known as theorem proving.
Theorem proving. So it's like proving why those geometry rules actually work, not just plugging in numbers.
Exactly. It's about constructing logical arguments, step by step, to prove mathematical statements. And geometry, with all its visual and spatial elements, has always been a particularly tough nut to crack for AI.
Because it's not just about crunching numbers, it's about understanding shapes and relationships.
Right, precisely. It's like teaching an AI to see mathematical concepts, not just calculate them.
Okay, now that is pretty cool. So how does this alpha geometry actually learn geometry? It's not like it's sitting in the classroom with a textbook, right?
That's where it gets really interesting. Unlike previous attempts that relied on pre-programmed rules or human-translated proofs, alpha geometry is a self-taught prodigy. It uses something called synthetic data.
Synthetic data. That sounds pretty high tech. What exactly is that?
Imagine, instead of learning chess by studying grandmasters, you just played millions of games against yourself, figuring out the strategies as you go. That's kind of what alpha geometry does.
So it creates its own training ground, its own set of practice problems.
Exactly. It generates random geometric premises. Think of them as star diagrams with points, lines, circles. Then it uses two internal engines, DD and AR, to make deductions based on those premises.
DD and AR, those are like its logic processors or something.
You could say that. They allow alpha geometry to make basic deductions, like if these angles are equal, then these lines must be parallel. It's starting to see the relationship between different elements.
Okay, so it's building some basic understanding. But how does it go from those simple deductions to solving really complex problems?
Well, that's where things get even more interesting. Alpha geometry is designed to identify what are called dependency differences. These are basically points where those basic deductions hit a wall, where you need a creative solution, a new construction to move forward.
So it's like it's driving along, following the rules of the road, and then it hits a dead end.
Exactly. And here's the kicker. Alpha geometry not only identifies those roadblocks, it figures out how to overcome them. It comes up with its own constructions, its own strategies to solve the problem.
Now that's impressive.
Ah,
So it's not just following a set of instructions, it's actually coming up with its own solutions.
exactly.
Yeah.
And that's what makes this research so groundbreaking. It's pushing the boundaries of what we thought AI was capable of. But to really appreciate how impressive this is, we need to see how it stacks up against, well, actual humans.
Right, because AI playing against itself is one thing, but how does it fare against the best human minds in geometry?
That's the million-dollar question, and it leads us to the most exciting part of this research, the results.
Okay, you've definitely piqued my curiosity here. This AI is building its own understanding of geometry, coming up with its own strategies.
Mm.
But how do we know it's any good? How does it stack up against the real deal?
Well, to put alpha geometry to the test, the researchers pitted it against a set of problems that even the smartest humans find challenging. We're talking about the IMO AG30 benchmark.
IMO, right? The International Mathematical Olympiad?
Exactly. Think of it as the Olympics of high school math and the AG30 benchmark. Those problems are designed to test the most advanced geometric problem-solving skills.
Okay, so we're not talking about your average high school geometry quiz. These are Olympian-level challenges. So how did alpha geometry do?
It exceeded everyone's expectations. Alpha geometry managed to solve 25 out of the 30 problems in the IMO AG30 benchmark.
25 out of 30. Wow.
That's incredibly impressive, even when compared to the best of the best.
Yeah.
To put it into perspective, that's better than any previous AI system designed for this kind of task. It's even surpassing the average score of an IMO gold medalist.
Hold on, you're saying this AI is outperforming students who've dedicated years of their lives to mastering these incredibly complex geometry problems.
On this particular benchmark, yes. But it gets even more interesting. You see, alpha geometry doesn't just spit out the right answers. It actually generates human-readable proofs, step-by-step explanations of its reasoning.
So we can actually look under the hood, so to speak,
Yeah.
see how it arrived at those solutions.
Precisely. And these aren't just rough sketches of a proof. They're detailed, logically rigorous explanations that meet the same standards as those written by human mathematicians. In fact, these AI-generated proofs were reviewed by a seasoned IMO coach.
Okay, and what did the IMO coach have to say?
The coach confirmed that AlphaGeometry's proofs were clear, concise, and worthy of full marks. It's not just solving problems, it's solving them in a way that genuinely advances our understanding of the underlying mathematical concepts.
That's amazing. But I have to imagine there are still limitations. No system is perfect, right?
Hmm.
What are some of the challenges AlphaGeometry still faces?
You're absolutely right. There are some areas where AlphaGeometry still has some catching up to do. While its proofs are logically sound, they sometimes lack the elegance and efficiency that you might see from a seasoned mathematician.
So it's getting to the right answers, but maybe the path is a bit more, shall we say, convoluted than a human expert's.
That's a great way to put it. You see, alpha geometry is relying on a much more fundamental set of rules and deductions. It's like comparing a novice cook diligently following a recipe to a master chef who can just improvise and create something truly extraordinary.
Good analogy. So are there any problems that AlphaGeometry just hasn't been able to crack?
There are a few. Problem 6 from the 2008 IMO, for example, that one remains unsolved.
What is it about that particular problem that's tripping it up?
It seems to require a deeper level of intuition,
Yeah.
an ability to connect seemingly unrelated concepts, something that human mathematicians, at least for now, still excel at.
So AlphaGeometry is impressive, but it still has room to grow. But even with its limitations, we're still talking about AI that can go head-to-head with Olympians and generate clear explanations for its reasoning. This has huge implications, and not just for the world of math, right?
Absolutely. The implications extend far beyond geometry, even beyond mathematics as a whole.
So we've got this AI that can go toe-to-toe with Olympians in geometry, even to explain its reasoning. That's mind-blowing in itself, but you're hinting at something even bigger here, right? This goes way beyond just acing math tests.
You're absolutely right. Alpha geometry is like a peek into the future of problem solving in general. It's not just about triangles and circles, it's about a whole new way for AI to approach complex challenges.
So if we zoom out, what's the bigger picture here? What are the broader implications? Paint me a picture.
Well, think about it. Alpha geometry's approach, this whole idea of using synthetic data and language models to guide reasoning, it could be revolutionary for all sorts of fields. The research paper specifically mentions its potential in other areas of mathematics, like proving inequalities.
Okay, so beyond just shapes and angles, it could be tackling even more, let's say, abstract mathematical concepts.
Precisely. Imagine AI working alongside mathematicians to crack those age-old problems that have stumped us for centuries. Or even helping us discover entirely new areas of math we haven't even thought of yet. It's like giving mathematicians a superpower.
A turbocharged brain boost. So it's not about replacing mathematicians, it's about giving them a powerful new tool.
Exactly. And the applications go way beyond just math. Think about fields like computer science, engineering, or even medicine.
Okay, now you're really getting my gears turning.
Mhm.
How could AlphaGeometry's approach revolutionize those fields? Give me some concrete examples.
Well, imagine using AI like alpha geometry to design more efficient algorithms for complex calculations, or developing new materials with specific properties by simulating their behavior at a molecular level.
So it's about using AI to find those hidden connections, those subtle patterns within huge amounts of data that humans might miss.
Exactly. And remember how alpha geometry can actually explain its reasoning? That's crucial. We're not talking about some black box spitting our answers. We can actually understand the why behind the what, which means we can learn from it, adapt it, apply those insights elsewhere.
That's a game changer. It opens up possibilities for a whole new level of collaboration between humans and AI, each playing to their strengths.
Precisely. It's not about AI replacing us. It's about AI augmenting our abilities, helping us reach new heights of understanding and innovation across countless fields.
This has been a mind-expanding deep dive. It seems like with AlphaGeometry, we're really just scratching the surface of what AI can achieve. A huge thank you to our expert for taking us on this incredible journey to the cutting edge of AI and mathematics. Until next time, keep those minds curious.